Hello everyone, my name is Barbara and I would like to welcome you all to our latest Novedge webinar episode. This week, Fusion 360, your CAD tool doesn't have to get in the way of great product design. Learn how a modern product design platform like Fusion 360 can deliver you and your team the flexibility and accessibility of direct or parametric modeling, whether it's in PC, Mac, or mobile, online or offline, you choose. Today's presenter, Jeremy Stadtmueller, is a degree mechanical engineer, and he is an 18-year veteran of the CAD industry. From as a Windows-based design working at SolidEdge to SolidWorks, Jeremy's skills have been tested over the years, successfully developing some of the most complex benchmark models ever attempted in today's CAD system. He thrives on new design challenges and never met a model he could not build. What a pedigree! Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of design solutions that cater to virtually every software needs. So put us to the test and come visit our website at novedge.com. And for more daily software news and limited time promotions, pay a visit to Novedge blog or follow us on Facebook, Google+, or Twitter. Coming up in 2 weeks, BIM for the design-oriented firm with Vectorworks. Last but not least, today's webinar is free and is being recorded live. So if you want to rewatch this or any webinar episode in our collection, just head on over to Novedge's YouTube or Vimeo channels. And now, without further ado, I'm going to transition to Jeremy, sorry. I scared you for a minute, right, Michael?
That's right.
And
This would get interesting.
Jeremy is going to share his screen and get started with this great presentation. Take it away, Jeremy.
All right, thanks everybody. Hey, it's really great to be with you today. As Barbara mentioned, my name is Jeremy Stadtmueller. I work for Autodesk. And today we're going to be looking at Fusion 360. This is the latest and greatest design tool offering from Autodesk. And when we say design differently, I want to kind of give you a little bit of the philosophy and why we built this and what we mean by designing differently. So Fusion 360 is a brand new design tool. If you're currently using a CAD tool, whether it's a mechanical engineering tool, design tool, or even a basic tool, odds are it was built somewhere around 1995. So let's take a little bit of a look back at some of the technologies that were available in 1995. If you were around like me and looking in the industry, things like this Silicon Graphics Octane computer, that was state of the art. You passed data with zip drives. If you had a cell phone, which was a pretty big if in 1995, it looked like one of these. Coolio was ruling the charts in 1995, and if you were really at the top end of technology, you might have had an Apple Newton, but it was a colossal failure because the world wasn't quite ready for it. The other thing is, how did we communicate? It was much, much different back then. The operating system of choice, Windows was just really coming up to speed. Windows 95 kind of for personal computers, and then Windows NT was becoming a business tool of choice. But you were just as likely to be running on a Unix machine as you were a Windows machine if you were an engineer or a designer. And the internet, well, it existed, but I'm not so sure you could say the World Wide Web was really in full swing yet. If you were using a browser, you were using Netscape Navigator. You can see that picture up in the upper left-hand corner. Odds are you were sending mail via a memorandum or snail mail. The reason I take you back here is this is the world that current generation CAD tools were built for. They were built large file structures. Most engineers worked on a single workstation. It may or may not have been networked together. The file structure and organization was based on that operating system. Communicating overseas, much less to the building next door, was difficult, handing data and models off. And so the software was architected for that. And there's only certain architectural things that you can modify as systems evolve. So current design tools really struggle in today's modern world. So if we're going to build a new design tool, what do we have to look at? We have to look not only at the technologies that have changed, cloud, additive manufacturing, distributed design environments, but even how does your CAD tool operate? It would have been really easy for Autodesk to just kind of mimic some of the other leading tools of the market today and try and get you to switch to our platform. But this fairly well-known quote from Albert Einstein really rings true when it comes to design for me. And the purest form of insanity is to leave everything the same and hope that things will change. I just butchered that, of course. But if we attack problems the same way, not even at the architecture level, but at the software usability level, what problems have we really solved? So let me be really specific about those. In most current design tools, you have to plan way ahead to design your assembly. You might not even think about it anymore. You've probably been trained over and over and over again. All your classes, all your best practices sessions you've taken from your vendor or your reseller have helped you, like, okay, if I'm going to create an assembly, I need to lay out what's going to be a part, what isn't going to be a part, what's going to be a sub-assembly, what's not going to be a sub-assembly. And Lord help me if I'm going to create inter-part relationships from one assembly to another sub-assembly, and what layers do they go in. And really, to make your assembly really work, you better plan ahead, and a little bit of hope and a prayer that when you make your changes, things will fall out. So is that really a good way to work? I mean, how much effort do you have to go into? How much creativity are you losing? So if you make a mistake, or you're working in a team of 20 people, one of them makes a mistake, next thing you know, you make an edit, and you end up with that glorious tree of red. Christmas is coming up. It's not the happy kind of tree of red we're talking about here. You make a change. I didn't really realize that dimension I changed affected this part, and that part. And that's part of the way it's architected. That's part of the way, because the way the system's architected, the way the files talk to each other, the way the assembly solver works. And it makes for a lot of pain. I'm not saying that Fusion is perfect. I'm not saying you can't break Fusion. But we don't solve things, we don't do things in a similar fashion, in the same way that mainstream tools today do them. We're enabling you with cloud communication, cloud processing, integrated manufacturing with additive manufacturing and things of that nature, as well as entirely new methodologies that free you up. The bottom line, there is going to be, if you're an existing CAD user, you're going to have to learn what you have learned, as a wise green man once said. If you've never used a CAD tool before, oh, I know you're going to love Fusion, because you don't have any of that head trash. What did I have to go through to get there? If you have used a CAD tool before, once you forget all that extra stuff you have to do, you won't believe how free your life can be in terms of design. So let's get practical. Let's take a look at a model. So I just kind of wanted to give you a little bit of the why. When Windows CAD tools came out in the 95, 98 time frame, they were solving a problem that most people couldn't afford a Unix workstation and a $30,000 piece of software. So they were solving the problem of putting CAD on a Windows platform. Fusion is solving so much more. We're not just CAD on the cloud. How pedestrian. That's great, but you're really only solving one problem. We're trying to solve design collaboration problem using a new platform. Manufacturing techniques have changed. Additive manufacturing has been added. How do we better communicate with 3D printers? How do we better communicate across the globe? As well as full-blown usability. So let's take a look at it, okay? So this here's Fusion 360. This is our Ember printer. You may or may not know that Autodesk makes a 3D printer. This is it. It's a desktop printer. It's very, very cool. But Autodesk is a software company. Why are we making a 3D printer? Carl Bass, our CEO, has a very practical approach to manufacturing. He has changed the way that Autodesk approaches manufacturing. It's very exciting. It's one of the main reasons that I work here. And I think of the Ember printer, and we think of the Ember printer to a certain extent like the Nexus phone from Google. Google doesn't really particularly want to be in the hardware business. They're a software company. Yes, they own Motorola, but in general, the Nexus phone isn't intended to own the cell phone market. The Nexus phone is intended to be a beacon, a lighthouse for what's possible from the Android operating system on a mobile device. Why does Autodesk build a 3D printer? Well, a major reason is, how do we better understand how 3D printing technology has evolved and how 3D printing technology communicates with design software than doing it yourself? There's all certain things you can only learn by doing yourself. So I love that we're doing that, and we're investing money in that to help better understand how you, the designer, does work. So we'll take a look at this. This here is the printer. This is Fusion 360. You can see it's got a nice, sleek interface. It runs on a Mac. I am currently running on my Mac. I'm in our office in Detroit here today. I live in Milwaukee, Wisconsin. Back in my home office, I have a Windows machine that kind of sits there plugged in all the time. I move back and forth between them. The data is always synchronized, and I can use the application on either. Fusion 360 has multiple ways to access your data. We are a thick client currently. It's a very, very small install. We go from click on average, click on a website to install in under 8 minutes. Streaming updates in 2 minutes. Major updates in 4. There's no such things as versions in Fusion 360. Am I in 2015, 2014, 2013? Everyone's always on the same version. Solves a lot of problems. Licensing, we handle all of that for you. No problem. A lot of those headaches that just get in your way. But here we have the printer. And what I really want to do here is, I want to show you. It's an assembly, multiple different subs, linked assemblies. We've got assembly tools, sketching tools. We've got patching tools for surface design, rendering, animation, built-in simulation, linear static simulation. That's part of the product. CAM, 2.5 axis, 3+2 axis, turning, water jet, all built into the software. But let's go ahead. This is a desktop printer, okay? So I want to go ahead and add a handle to the top of this. Let's show you some of the specifics that really to show how Fusion gets out of your way, how Fusion just lets you build and you go from there. So we'll go ahead and we'll open up the top level assembly. I've just opened it up in its own window. Easier for me to kind of just look at the area that I'm going to work on. And we have our feature tree down here on the bottom and a list of tools that are in here. But let's just start by creating a sketch. So I'm going to go ahead and create a sketch. I'm going to pick a mid-plane on my particular view. You can create reference planes wherever you want. You don't have to. You can pick individual faces wherever you need to on the model. And here we are. Okay. So as we look at this, we're going to go ahead now and just draw a rectangle. Fairly straightforward, right? We'll go ahead and click and pull. I'll reference geometry directly from the model, like so. I can grab it, add the rectangle. Notice it does include the edge from the model in purple down here in my sketch. Why? Because it's visually letting me know I've created an external reference. I've got a graphical icon that says, hey, you've created a coincident relationship, but that line exists on another model in the part. I don't want to accidentally create that relationship. That's a lot of complexity. We talked about how do I manage those relationships? How do I minimize those problems? This is one very simple way to do that. So let's go ahead and just start adding some more constraints. So I'll use this hole, and I'll right mouse click and grab the line command if I want. From there, something new in our latest release, it came on Sunday. Sunday night, in an hour and a half, we pushed out a brand new release on the cloud. When I updated it from my hotel internet, because I was on the road this week, my hotel internet, it took me 7 minutes to do a major update. That's on hotel internet. If you've stayed at a hotel recently, you know that is awful speeds. And especially around dinner time when everyone's sitting there streaming their videos. I was so impressed. The other day I was on the way to a customer driving through Pittsburgh, going through tunnels on a cellular connection, and I did a minor update in 1.5 minutes. I don't have to do anything, it just did it, but it works. It's so fantastic. But something new in the update, look, I can bring up a shortcut menu. It works no matter what environment I'm in and changes. So let's say I don't want line, maybe I want an ellipse. I can start typing. There's my command. Put it up to the top, and away we go. So it really, all my tools at my fingertips. But we'll go ahead and just draw a line here, and we can pick the midpoint. You see I'm getting nice graphical feedback from my cursor, and there it is. If I want this to be, for example, vertical, I'll select and add that relationship right from my sketch palette here. What about specific dimensions? I'll come up here and I'll go ahead and add a dimension. Let's say, let's make this 25 millimeters. And then maybe I want an offset from the bottom edge here to the top. And really, we're looking for about 3.5 millimeters. So I'll add that, and I've added the relationship. The geometry is changing. It's changing from blue to black as I add those relationships. Let me know I've constrained them, but I don't have to. I can just click and move and push things around. So it's pretty awesome. So I've got my piece. Now look, I accidentally created my sketch on the wrong reference plane. No problem. We'll go ahead and hit stopwatch. I can just right mouse click and redefine the sketch plane and pick this sketch plane here, and it moves it, and everything's fine. Total editability from within the system. But I wonder if any of you have noticed what I haven't done so far. I haven't created a new part. I'm not editing any particular part in the assembly. I've just started sketching. Think about the way that you do your design today. You will probably have to either, if the part didn't exist, you have to create it. Does it have a part number? Where does it go? How do I want the origin? I better lay that out, so on and so forth. A lot of things you have to think about before you go. And it's not just the part number and where it's going to be, but as I create, which features, which bodies are going to be part of which part. It's all stuff you have to think of ahead of time. That's a lot of work when really I'm just trying to get my idea out there, lock it down, and then add that structure or information later. So watch, as I come in and I'll say, okay, and I love, guys, I'll be honest, I messed up. I meant to put this on this middle plane, but I put it on the outside plane there by accident. I just did a quick mispick. Fusion's so nice and robust and just allowed me to move it and go along. It's really well thought out, well done, and robust. So I'm going to right mouse click and I'm going to use a tool called press pull. We'll talk a lot about press pull, but what it is a feature with all the features, a lot of the features built into it. That seems kind of like an odd way to put it, but watch what happens. When I click press pull, it doesn't really have a description per se. But I go ahead and pick a sketch entity, and it recognizes, well, if you're picking a sketch entity, I'm guessing you would like to extrude. Of course, yeah, that's what I do want to do. So it's just kind of like, hey, I'm going to press and pull geometry or something. Give me the appropriate operation. So I want you to look here. I'm in version 39. We have built-in Fusion, built-in data management. When you think back to 1995 when they built those systems, SolidWorks, PTC, even Inventor later on, Unigraphics, data management wasn't really an issue because there wasn't as much networking and things like that. And when they added data management, when networking became more powerful, it was a bolt-on, and the software wasn't really built for it. So you got to kind of work around some of the constraints of that. Not so in Fusion. It's all just inherent. When I save, I get versions. With Fusion, you get unlimited storage on the cloud, unlimited collaborators, unlimited projects. We're not going to nickel and dime you to death. So watch though. So here I am. You can see it's highlighted that top cover assembly start is my active component. Okay? You don't really need to know that, but I wanted to show you that that's the case. Now watch what happens as I start cutting. I pull out, so it says, oh, well, if you're pulling a sketch into a solid, I'm guessing you want to cut, so it switches that. But look what automatically happened here. It automatically activated top extrusion 1, which happens to be this part, because that's the part I'm cutting. And it's going to automatically put that feature in this part. I don't have to think about that. It will just do it. What if I say, I don't want to cut, I want to, let's make this, say, 32 millimeters, and I want this to be symmetric, and I want it to be a new body instead of a cut. Watch my tree on the left-hand side. Watch my browser. New body, boom. Top cover now becomes the top-level assembly, and I've started creating a new body or piece of geometry in the assembly. As soon as I hit OK, a new folder is created saying, hey, this top-level assembly has a body in it, as well as a sketch. Those sketches, that stuff can operate on any part in the assembly. The bottom line is I can start modeling, and when I decide I want something to be a component or part, I can do that. Really, the structure is more about bill of materials. And why do I care about, do I have to care about bill of materials at the beginning? Maybe. If you do, you could always just start and build the structure like you used to, but you don't have to. You have this flexibility. So let's go ahead and take a look here, and let's say I want to cut this block so that it slides. I'm going to go ahead and use the combine command, and here, I'm not in a sketch anymore. Watch what happens when I bring up my shortcut key. I get a different toolbox. And I can say combine, and there's my tool. I'll probably use that one a lot. I better add it to the toolbox, and then click it and go. So let's combine this particular body, and I want to cut it with this one. We're not going to join, we're going to cut, and I would like to keep the tool. So when we hit OK, what it does is it just cuts and creates the individual bodies that are in there. I can leave this body here and just turn it off, do all sorts of different options, but now I've cut that track quickly and easily. So far we've seen some pretty cool ways that you can model and assembly model and top down, but what about other things? If you're going to start a new design tool and you're a company like Autodesk that has some world-class surfacing applications like Alias, what about, you know, different mesh modelers like 3D Studio Max or Maya? Did you know that Autodesk has won like something like 17 Oscars in a row, Oscars for the last like 17 years in a row for all their animation software? Well, some of that stuff might be useful, and graphic and special effects, some of that stuff might be useful to a mechanical designer or designer. I keep saying mechanical designer. For a designer, why not just give more tools? So for example, let's go ahead, I want to create a sculpted handle. So I've got sculpted surfacing. That's why this is called Fusion. Fusion 360 is the backbone for the future of what Autodesk is going to be. This is the platform that all of our tools will eventually end up migrating, moving to as appropriate. This is our next generation platform. And do we let you work locally? Absolutely, because what happens if your internet goes down? What happens if you have a mediocre connection? We want to give you the option to either work online or offline, and Fusion does that. Coming next year, full online mode. If you want to just access it through a browser, you can. However, you can pick and choose when you want to do that and when it's appropriate. So we're not going to force you to be on the bleeding edge of technology. So let's go ahead, and I'm going to create a locating sketch for this particular, for the handle that I'm going to create. So we'll go ahead and slide down here, and I'm going to go ahead and grab the top edge of this part, grab a line from the midpoint, come up, and let's say I want to go up about 20 millimeters. Hit tab, lock it in place. There's my line. Pretty straightforward, pretty easy, you know. So we've got this guy. I can make sure that it's horizontal, vertical. There we go. It was, but I can always just make sure. And it finished, and there we are. But now we want to go ahead and create that handle. So I'm going to go ahead and hit Create Form. What Create Form does is it says, hey, you're entering a sculpted environment, which is inherently non-parametric. We're including non-history-based modeling tools, which are very, very powerful, especially for imported data. I would imagine, I'm going to throw it out there if Barbara's listening eventually, that we should do another seminar like this, and we'll talk to you about using Fusion to import models and integrate them in your environment. You're going to love it. You're going to love it. It's awesome. But anyway, so we'll do that soon enough. We'll say, okay, so we're entering the sculpt environment. It's just warning me because it's giving you tools that you may not be used to. And if you're a parametric user and you're used to just always dimensioning everything and locking it down, this is going to be a new skill for you. So it's warning you, you're entering this. If you want, when you're done and want to go back to regular solid modeling, hit this Finish Form button and you're done. We'll go ahead and create a cylinder for this guy, like so. And I'll look at the right-hand view. Sorry, my GoToMeeting thing got in the way a little bit. And we'll go ahead and create a cylinder. And how big do I want that cylinder to be? Let's say 30 millimeters. And there it is. Click and add it. Let's do that again. It was so easy. I just want to make sure you guys can see how easy it is to create. And it's just a cylinder, I know. So you're like, well, Jeremy, what's the big deal? It's just a cylinder. Because it's got a lot more power than just a cylinder. So we'll grab this. We'll say, I'm a terrible typist, so pardon my delay, 30 millimeters. And then how long do I want it to be? Let's say, for example, 40 millimeters to the right. But I've got all these patches. What are these patches? These are subdivisional patches that I can use to mesh, that I can use to create this surface. I can even add symmetry and things like that. So what does that mean? I mean, it's a cylinder. It's exactly 40 by 30. What's the big deal? Well, this is a sculptable surface. Watch, I can push and pull, and it maintains curvature continuity. Pretty awesome. What if I did want symmetry? I didn't add it at the beginning. Can I add it after? Absolutely. Click and place. We'll pick corresponding surfaces on what I'm considering the left and the right and put in symmetry. Now watch what happens. Edit form, I get symmetry, live active symmetry for my model. All right, so we've got that. We'll say okay. I'm going to go relatively quickly here because we're kind of short on time. But I want to take this and I want to make this the shape of kind of a hand grip. So we're going to go ahead and insert a canvas. I'll pick the face here and I'll go out to my hard drive and I'll just grab a PNG file. So let me come in here and I'm going to do grab a folder, grab a PNG file. Could be just from the web and add it to it. And there it is. We'll rotate it over maybe 90 degrees, scale it up, be a little bit bigger, and slide that guy up here and take a look at him. So it's about where I want it to be, but I want to bring the opacity down a little bit. Hey, display through, that'd be great. I don't need it to be selectable because it's just a background canvas. We'll just say okay and move on. But how big really is this? It's pretty sweet. I can come in and say, all right, well, let's calibrate from the left side here to the right side here. And if you recall, I made the original cylinder 40, so why don't we do double that, 80, so it's left and right, and there we are. So we'll say, okay, let's go ahead and put this a little closer to where I want it. We'll drag it down. We'll move it over here like this, and there we go. Now I want this to make this cylinder have a nice grip to it. The problem is I don't have any control edges here to pull up and around. Watch as I come in. I'll use Command and Mac, Control and Windows. Right mouse click and just say subdivide, and it subdivides those four patches into technically 16. By default, it's simple, which means it added complexity, but that means that the cylinder needs to change shape. You see how it's a little bit deformed? That's okay. If I want it to be exact, I can. What we're doing here is giving you this ability to add complexity as needed. And there we go. We've got this. Looks good. We'll look at the front. And let's go ahead and double-click these two edges, slide over, hit Edit Form, and pull this up like so. And look at that. Is it accurate? Of course it is. I'll go exactly 9 millimeters up, and there we've got our shape. What about this edge over here? I want to bring that up a little bit too, but watch what happens. As I drag this, it's influencing. There's nothing to buffer between these two edges, so there's a lot of movement happening. Can I undo? Of course. Every little push-pull I have has an undo, and in fact, here we'll go all the way out of this edit form here, and take a look. Everything I've done is in my undo, including a tiered undo for all the push-pulls that I did in the edit form. Really nice and awesome. Okay, so we'll say, okay, now I like where I'm at with this. Okay, let's just go ahead and hit save and say started, well, I'm such a terrible typist. Started handle. Hit OK. It's saving this locally, and I keep working, and then it's pushing it up to cloud in the background. So I don't have to stop working or worry about my connection. But let's say I want to move this. Now watch what happens. So let's grab this edge, and I'm going to hit Edit Form. I've even got really finite control, like soft modification. What does soft mod mean? Watch what happens. As I click and add and move this, I get a grid. Everything in dark red is going to move a lot, and if it's in white, it won't move at all. And I can change that distance. I can slide that influencer. How much movement do I want? So let's drag this up. Watch this. I can show how much more influence I can get. And I can seriously control that movement, but it's a numeric. Look at how smooth that ends up being. And I can really, truly, finely control things. So it's really awesome. But really what I want to do is pivot this a little bit different. So watch, I can come in, use Insert Edge, add another piece of geometry at minus 0.75 or 3/4 of the way between this line and that line. There we go. Now watch what happens. When I edit form, I got a pivot at that line. So I can just quickly and easily click and move. And we've got all sorts of fantastic tutorials to teach you how to do all this stuff. In our YouTube channel, we're developing a new way to distribute and distribute software, create software, and why wouldn't we use new and modern ways to learn software? So we're using the YouTube channel, we're using online blogs, we're using forums as best we can to help you learn to use the software. So here it is. But as I look at this, you know, It's a little wide at the bottom. My fingers are going to have a hard time getting around there, so let's go ahead and window select these guys. I'll use edit form to scale them down, maybe exactly 65% smaller. Oops. Again, terrible typist, minus 0.65. There we go. Here, let's cancel that. I'm going the wrong way. That's why you got to love undo, right? There it is. Okay, so we've got it slid in there. Looks good. What about this edge? You know, this is the top of a handle, and it's going to hit the palm of my hand. I don't want a point that's kind of sharp like this at the top. Watch, I'll hit edit form, and I'll just start dragging those surfaces and with those edges. And with symmetry, I can come up exactly 3 and over exactly minus a half, and I've got a flatter surface for this. Lots of great options. All right, so this surface is fine and all, but how do I integrate it with the prismatic piece that I created over here? All right, well, let's come in, and I'm just going to go ahead and use convert to say, let's take this surface and slap a sculptable surface on top of it. Won't get into a lot of the details, but watch, I can come in and just boom, 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 take these, and I'm going to delete them, and I want to join this set of edges with that. Some might call it a loft. We do have lofted commands, but in surfacing, it's really more of a bridge, because the difference between a loft and a bridge is this. First of all, I'm going to loft from here, a bridge, excuse me, from here to here. Can anybody see a problem? I even get an error. The edges don't match. That's not a requirement, but it's nice. And I can even, I noticed I've got a little bit of dip there based on how I drew it. I can pull this up maybe a millimeter, and I know exactly where it is, like so. But if I want to add complexity, how have you ever done that with a loft? Maybe you split your segment, your sketches into extra segments just to have the right number, and then that sketch is inherently more complex, so then when you make dimensional changes, it makes kind of a mess. Well, with new tools, I can just come in and say, hey, let's subdivide this. Remember we picked exact before? Here, in order to exactly maintain this surface shape, I got to add a lot more complexity. I don't really need this hole here to be exactly the same shape as before, so I can go to simple, and I've reduced the complexity. That way it's not like a quilt, right? Like where you pick one point on the quilt and it makes an undulation or a point that's really a pain to get going. It's bringing complex surface tools to the average designer, someone who's not degreed in years and years of training to use. That's ease of use to me. That's one thing that I define as ease of use. So let's go ahead and bridge this. Now imagine, try and think, how would you do this in your current CAD tool? I'm looking at this, I'm going to bridge it. Let's look at a preview. The difference between bridge and loft is I control the number of faces. So if I do 3 or 5, I get a different shape based on the number of pieces I put in there. And we'll say okay, and it adds it. I'll get to this error message later, but what it's saying, oh no, I'll do it now. What it's saying is, see how this is symmetric? The surface I just bridged to was not. So it's warning me, hey, if you think that this part in red is symmetric, it isn't. So be careful. Great feedback. And that's what the error message basically said. So we'll hit that. This is really kind of pinched. What if I just pushed and pulled that away? How would you fix that in a standard loft in your CAD tool? A lot of guide rails, a lot of surface and normal extrusion edits and changes. It's a lot of work, right? Let's try even a different method. Hey, okay, I want even more finite control. Let me double click this edge. I can hit edit form. I can pull it off maybe a ½ millimeter. I'm typing numbers not because I have to, just to show you how accurate you can be. And then watch, I'll use the Alt drag command to add another set of surfaces like that. Super easy. Pull it off 5 millimeters and we're done. Maybe I want it a little bit smaller. Look, I can scale it down, 0.9, like that. And I'm creating that geometry. Now let's go ahead and bridge from here to here. Same command, same operation, but I've already kind of put that away. So just a different way of doing it, you know? But the options are there for you. It's a little thick. Here, I'll just use Shift and edit form and do a 3D scale and maybe neck that sucker down by 0.7 or 70%. Or neck it down by 30%. So 0.7 would be 30%. And then, you know, push and pull this up a little bit, and there's my handle. Again, I'm just kind of checking it out. So this symmetry doesn't work. So how do I fix it? We'll hit clear symmetry and hit OK, and it's gone. Let's go ahead and hit finish form. It automatically converts that mesh into a surface that I can use, but it is still just a surface. Watch as I come in and say, all right, well, I want to make that a solid. Let's use boundary fill. Boundary fill allows me to say, take a surface, solid, any number of other geometries. Like, for example, it can find that there's a solid here, but this is still open-faced. How do I close that off? Well, let's use the reference plane I used to draw on. So you can see I'll come down. I'll pick that one, and that caps the end off to make a solid. What do I want to be a solid? We'll pick this and that. Hit OK, and now I have a solid. Just like that. Solid body. I can come in and I can say, you know what, I don't need these original pieces. I can delete them, I can remove them, I can do whatever I want to them. Like so, and there they are. Doesn't matter, just a little housekeeping if you want to. Sometimes I get a little bit of OCD about that stuff. Not necessary, but we're all to each their own, right? So we'll come in and we'll say, okay, I need both sides of a handle. This is going to be, this might work, but let's mirror this body, this body about its side face there. We'll hit OK. Remember the shortcut key? I added combine to it. Let's go ahead and combine these with a join. But guess what? I want to, at this point, I've decided that this is a handle now. So when I check this one simple little thing, new component, notice down here the last part in my assembly, last component in my assembly, metal A badge, and join. It says, oh, I've made a new component, move that body into the component, and I can just name it handle. And just like that, I've taken everything that I've done and put it into a component. And there we go. Now, what if I wanted to make an edit or change to this? Like, for example, boy, I really want to edit this shape. Remember, it's history-free here. And where'd that symmetry go? Remember, I got rid of the symmetry. Can I add it later? You bet you can. Re-add it. Look at that. Found symmetry for the model once again. And maybe now I want to take those two edges that we were playing with before, hit Edit Form, and maybe I'm going to drag them down a little bit and back in or out. We'll make it a little more short and squat. You can see the difference. Watch what happens. Hit OK. Finish form. Rebuild, rebuild, rebuild. A non-history, a history-free feature in a history timeline, combining multiple techniques, surfacing, mesh modeling, solid modeling, parametric modeling, all in one. Oh yeah, can I render it? You bet you can. Go to Appearances. It'll launch the library for my appearances, and I'll say I've got one in here, but look, I've got different paints, glossy, metallic, yellow, powder coat, you name it, all sorts of different stuff in here, different metals, bronze, lots of great stuff. We'll just do a red paint in there, and there it is. So we'll go ahead, and that's the model. So we've got the old pieces there. We don't need those anymore. We don't need this guy anymore. It's all still fine and robust. And we'll go ahead and hit Save. Say, handle benchmark 1. Basically what I'm saying is, hey, look, I've created this. I put it in place. This looks good for now, but maybe we need to do more, add more. So we'll say, okay, now let's go ahead and take a look at the assembly. Well, guess what? It's out of date. Let's do get latest. And it updates the assembly with the new version of the sub, and away we go. So because you want to be version specific, oops, but I forgot to add an assembly relationship to hold it here. Watch how easy it is to add an assembly relationship. Joint, handle, the rail, and I don't necessarily want it rigid. Maybe I want it to be able to slide based on this edge. And just like that, I've added motion and relationship, and I'll save it again. Hit motion, added, just to label my things. We'll come back to the assembly, and it will update with those new changes. But they're all, of course, version specific. You keep track of it. There's things that you do that different parts are going to have different versions. All that stuff is handled automatically with Fusion 360. So you can see here I've got my data panel here on the left. Everything that's up on the cloud is available here to me on the left-hand side. The preview's already updated with the handle that I've got here. I haven't saved the assembly yet, so it hasn't. But let's go ahead and take a look at what this looks like up on the cloud. So here's Google Chrome. In Google Chrome, here's the top cover part that we just worked on. In fact, it'll tell me. Here's the preview. Last updated at 11:25. Oh, did I grab the wrong one? Let's go ahead and grab this. It'll update with respect to that. There we go. And so, oh, it is. Do I have the date right? I'm crazy. All right, sorry, I get lost. It is, and so we can look at this. Here's different renderings that are automatically being created. These ones are out of date. They will update. If I want to select this view, I can do so. And it opens, remember, this is Google Chrome. No install required. Fully cloud. Here's the model that we just created. I can do an exploded view on the web. Explode the piece out. I can do section views of this guy, slide in and out, rotate, all in the cloud, all on the web, always updated. Pretty sweet. We can go in and look at properties. Here's the top cover. From there, we've got, where's the model browser as well. Really cool stuff. Do I want to look at previous versions? Absolutely. You can see it was updated 1 minute ago by me, handle benchmark, all the notes. So at any time, here's every version that I've ever saved. And I can promote it. So let's say I want to make version 39 the current version. I'll hit promote. It will make it version 43 and keep version 39. All inherent, remember, unlimited storage, and it's in the cloud. So what do you care if we track everything you do so that you can come back and leverage your old designs instead of starting over? What if you want to do something like, let's go ahead and comment on this and see, what do you think of my new handle? And I'll hit snapshot. It takes a snapshot of the view like that, and we'll hit post, and it posts it into the into my project on the web. And there it is, posted 1 minute ago. One of my colleagues, Roger Orban, posted 9 days ago on one of the things that I did. What if we want to share this model with someone outside our organization? Maybe we want to add a password. We'll add the password Novedge. Novedge. Set password. And I'm going to copy the link and close. So let's go ahead and open a new incognito window, right? For those of you browser savvy folks, you know that there's no, so all my logins and everything's wiped out. It's basically like a blank browser. We'll click here. If you have the link, here's what happens. Oh, this item is password protected. Novedge. Hit OK. Opens up. Anyone I send that link and give the password to will be able to look at and view this particular model the same as before. Give it a second to kind of upload. Oh, here. Hit OK. I think I mispicked my my entry, so it opened up a different browser doing something different, something a little goofy. But this link, sometimes it's a little, the internet here is a little slow, so I apologize. But the link will update. They can look at it. It's always live. So you get all that kind of collaboration. I can look in here. Here's all the different files that I have. Who's a member of this project? I can invite them to it. I have full control over all of that. Now let's go back and look at our assembly here, and maybe look at this guy. If I look under comments in there, there's my comment. What do you think of my new handle from the web in my Fusion assembly as well? I can right mouse click and say orient the view, and it takes the view in Fusion to the one that was rotated on the web and lets me look at exactly what the person who commented was looking at. It's pretty cool. What if I wanted to do a live review? In other words, let's take this assembly and start a live review. I'm not going to do it here in the webinar because it doesn't make a lot of sense because it's just me talking. But if I do this, it launches a session similar to the one we're in right now, like GoToMeeting, except that I could send any and all of you a link, and you can see my Fusion window and watch me model live over the web. That's all part of the software. It does not cost money per person. You can do that from web browser to web browser too, all part of Fusion. So maybe we'll look at finishing up here because we'll leave 15 minutes for questions. I want you to ask yourself, though, if you don't know, how much do you think this product costs? You know, let's see, SolidWorks, $5,000, maybe 4, maybe 6, depending. PTC, 8, 9 grand. If you tell them you're looking at something else, maybe it's 5, 6, or 4. But a lot of that negotiation, figure all that out. You know, Inventor would be the same from us, you know, that kind of thing. This is $300 per user per year. If you're a student, it's free. No rigmarole, no proving, you know, doing all this stuff. Just go to our website and get it. If you're a commercial user, go to Novedge's website and get it. It's $300 per user per year. No upfront costs. That's subscription and everything. It's a cloud product. You just pay $300 a year. You get all of this, every update, everything. It's also got, like, just to remind you, simulation built into the product, rendering, animation. Like if I go to the render environment here, I've even got cloud rendering. Sorry, some of the graphics get messed up when you're trying to run GoToMeeting and CAD tools at the same time. If you go to the render environment, it'll switch the rendering because the graphics card has to work very hard for all this sort of stuff because I'm recording and going. So all that stuff's part of it. I can do cloud renders for individual models. I can do all sorts of cool stuff from within here. So that's a little bit of Fusion. So here, so now we're in the render environment. You see it changes. It looks kind of nice. Fire off enable ray tracing. I've got texture mapping. I've got different environments. I've got decals. I've got all sorts of stuff. Local render, cloud render, $300 a year. So, questions. Team on the webinar, I don't see any questions right now, but I'm
They're coming. They're coming your way. First of all, please, can you tell us a little bit about the compatibility with Zbrush?
Okay, so if someone's using Zbrush, for those who don't know, Zbrush is a mesh modeler. It's used for very complex things, like you can make a dragon head with Zbrush. There's no specific integration with Zbrush. However, Zbrush can put out an OBJ format, you know, the mesh format. We can bring that in, and we can design to that, but this is not a mesh to surface conversion tool. We're looking at adding some of that stuff very quickly, but we can bring in meshes, we can design to them, we can model to them, and it works fairly well, but it's not a magic button for that. So I'll leave it like that. That might be a longer discussion, so we'd be happy to contact you and talk about it. But the capability does exist to bring in mesh-style data, think STLs and things like that, and work with them. Let's see here. Does Fusion have the ability to create true quad-based? Yes. So the question is, Fusion surfacing is quad-based by its default, and I think I answered that one. Organic mesh sculpting. We do not do mesh sculpting in Fusion. So, and the rest of it, you know, in terms of subdivisional quad modeling, I think you've seen, you know, we can split, add detail, add edges to it. You can refine your surface mesh models, but it's not ZBrush. ZBrush is very good for that kind of thing. But if you want, but ZBrush, the problem with ZBrush typically is that you can't create a manufacturable surface from it. You could print it, but it's tough. Fusion's kind of giving you a little bit of the best of both worlds and bringing them together. So it's not a one-to-one on any one of those things. But again, at least you have the ability, when you can design to it or put it in the background. It's pretty fantastic. And that's all part of the software. I'm not talking about a plug-in or anything like that. Here's some of the renders that we've done in Fusion as well, or for this Ember assembly as well. Okay, let's see here. How good of a tool. Question was doing modeling like the scale of a house. The size is immaterial. If you want to model every nut and bolt that goes in every hinge in your house, you know, that might be a little bit overkill. But the size is not an issue for Fusion in terms of graphics. I want to use Autodesk shape modeling tools. Question is some more of the specific Autodesk engines from Antonio. We are pulling technology from any and all of our products that are out there. Specifically, which ones, I can't totally comment, but absolutely in the future. And the thing is instead of giving you a box with 20 pieces of software in it, these tools, this mesh modeling and things like that, they're being rewritten for this platform and truly integrated for Fusion. So the question was, Autodesk has a lot of surface modeling tools and engines and you name it. I mean, we own VRED for rendering. We own, we got Alias. We got all these different things. As we see fit, we are grabbing that technology. Absolutely. That's the beauty of doing this from Autodesk. Can we transfer iGES or step files? Absolutely. So let me take a look here. Let's come back. If we look at the view online, I want to show you this. So remember I said you could send a link to someone? You can do that, and you can enable them to be able to download the file in whatever format they want from the web. So you don't actually have for them do it, and you can just send them a link to the model and say you download it in the format that you like, and it's always live. So if the model updates and they need the latest version, you don't have to do anything. They just go to the same link and pull it down. So you can do it from there, but you can also do it from the Fusion interface. Export, iGES, step, SAT, that kind of stuff. So that's the answer for that. Pause here. Other questions? Will Autodesk continue to support T-splines for Rhino? So the T-splines technology, that's surfacing technology, you can still, I believe you can still buy that for Rhino, but most of the development in that is going into the Fusion platform for sure. It's mostly for Fusion.
Great, Jeremy. That was awesome.
Thanks, Barbara. I appreciate it.
Those are all the questions, and I love when you said there's no thing as a version for Fusion 360. So you don't have to worry. It's always updated, and it's always there for you at this best potential. So come get it. That's all I have to say. And is there anything that Fusion 360 cannot do? No.
And you know what? I spend a lot of time trying to find that out, and it's a hard work to find the things we can't do.
Good. So, keep at it.
It's really fun. I love this product, and I'm really proud of it. So I hope you guys take a look at it.
I hope so too. And also, somebody is really interesting about shelling. Do you have any information?
So we could look at a particular model here, but I'll just show you. I have it right up here as shell. So here's the shell option. It's all in there. That tool. Shell, draft, scale, split body, split face for core and cavity stuff, chamfer, all that kind of thing. So yeah, those tools are all in here. Absolutely.
What about shell mesh?
No. Okay. Like I said, we are not a mesh modeler. I can shell the model that was generated from the mesh surface that I created, but in a mesh, we are not a mesh modeler. So we can leverage mesh, we can reference mesh. Fusion is not currently a mesh modeler.
Okay, and that was it with the questions. So thank you so much, Jeremy and Michael, for answering questions backstage. I will take back the screen and this webinar by thanking everyone for attending, and also remind everyone that to get Fusion 360 for that incredible price of $300 a year, just come over to Novedge. Here it is. Very easy. You can always talk to one of our salesperson if you have doubt, but it's very intuitive online. And for information on the latest specials and releases, join the Novedge network on Facebook, Google+, or Twitter. And don't forget the next week's webinar is actually in 2 weeks. Next week is Thanksgiving. So we have BIM for design-oriented firm in Vectorworks. And to rewatch today's webinar or previous one, check out our Novedge YouTube and Vimeo channels. Our webinar playlist has webinars for every software taste, and this particular recording will be uploaded right away. Give me a couple of hours. So thanks again for joining us. Thank you, Jeremy, for a fantastic presentation, and have a great day, everyone. And I'm going to take you up on our future webinar together.
Absolutely. I love working with you, Barbara. It's great. And thanks to everybody. Have a great week.
Bye.
Bye.